I had a bad headache yesterday, but then I ate some of those Tic Tacs. And a little while later, my headache was gone. I think I'm onto something here. Or maybe not. Today we will discuss how the regression to the mean can lead us astray. Welcome to the Soft Skill channel. My name is Sebastian Jung and today I'd like to present to you the regression to the mean. First of all, this is quite a common and harmless day-to-day phenomenon. It occurs for things that fluctuate around an average, for things that depend partially on predictable factors and partially on random factors. This is true, for example, for the weather, because on one hand we have things like geographical location or season, but on the other hand we also have random fluctuation. For example, it is June now and in my region the average max daily temperature is 21 to 23 degrees Celsius or 70 to 73 degrees Fahrenheit. Now, obviously, the daily temperature will fluctuate. However, if a day is really warm, several degrees above the average, I know that most likely the next days will be cooler again, closer to the average. And if a day is rather cool, several degrees below the average, I know that most likely the temperature will increase the following days and again approach the average. And it works the same way for personal performance, for example for athletes. Here on one hand we have things like genetics and training, and on the other hand again random fluctuation. Let's say Bob is a 100-meter runner. And he has his average time of, let's say, 12 to 13 seconds. I think this is okay. And on some days, Bob is in especially good form and he will run especially fast, several seconds faster than his average. But there are also days where Bob is in really bad condition and he runs much faster than usual. His time is several seconds below his average. And again, after an exceptionally good day, Bob's performance will most likely decrease again, approaching the average. And after an exceedingly bad day, his performance is likely to improve. And that is the regression to the mean. Now, so far, as I said, it is quite a harmless phenomenon. However, problems arise because we tend to make a common fallacy here. We tend to see causality where there is none, to make up cause and effect that are not really there. We observe this change that is due to the regression to the mean, this improvement or decrease, and we make up some explanation for it. Daniel Kahneman observed this when he was watching winter sports on television, ski jumping, and he listened to the commentator. And the commentator said things like, "Oh yeah, this person had a great jump yesterday. Now there is a lot of pressure on them and they have to protect their lead. They will be really tense and probably do worse today. Oh, and this other person, they had a lousy jump yesterday. So they have nothing to lose. They will be really relaxed today and probably do better." So obviously this commentator over time had noticed and observed the effect of regression to the mean. He knew that after an exceptional jump, the next one would most likely be worse, and after a really bad jump, the next one would most likely be better, and he made up some explanation for it. And there are more strange and funny examples, such as the Sports Illustrated cover jinx. Supposedly, an athlete or a team displayed on the cover of the Sports Illustrated magazine will afterwards suffer bad luck, a decrease of performance, and the career will go downhill. And there are plenty of explanations for that, such as overconfidence caused by the appearance on the cover, or the high pressure those people suffer. But the most likely explanation is merely the regression to the mean. Those people are on the cover because of an exceptional performance way above their usual average. And of course, this will most likely decrease afterwards, approaching their average again. Now, so far it's rather funny, but it gets really problematic if we attribute this change that is caused by the regression to the mean to some intervention we performed. And the best example for that is also from Daniel Kahneman from his book Thinking Fast and Slow. A story about how he held a lecture in front of Israeli Air Force instructors. He told them about training methods, and he emphasized that praise works much better than blame and criticism. Now, one of the Air Force instructors got up and said, "This is totally not true. I have frequently observed quite the opposite. If a pilot is doing exceedingly well, performs a complicated maneuver flawlessly, and I praise them for it afterwards, they will do worse the next time. However, if someone is flying really badly, is doing really bad performance, and I yell at them excessively, they will improve the next days." So, obviously, blame and criticism works, praise does not. Now, the observation made by this Air Force instructor was perfectly correct. He wasn't mistaken there. But his interpretation, his conclusion was wrong. What he observed was merely the regression to the mean, not the effect of his praise or criticism. By the way, what's also interesting in this story is Kahneman's reaction, because he thought to himself, "Oh, they won't be pleased if I do some lecture on statistics now," and instead he performed a simple experiment. He used a piece of chalk to draw a circle on the floor, and then every participant had to stand with his back to that circle and throw coins at it, 2 coins. And Kahneman measured the distance to the center of that circle for the first and for the second attempt. And he wrote it all down on a board. And after everybody was done, he sorted the results by the first throw, from best to worst. And it became quite obvious that those who did very well on the first throw, who were very close to the middle on the first attempt, usually did worse on the second attempt, and the other way around. Those who were really far off on their first attempt usually did better on the second attempt. And this was how Kahneman illustrated this effect of the regression to the mean to those Air Force instructors. Now, as I said, this is probably the best example, first of all because it is quite comprehensible, easy to understand, but also because it is so relevant, so important. Most of all, obviously, for teachers and people in leadership positions, but also for everybody. Because even in day-to-day life, we might draw the same incorrect conclusion. We might feel that if people are behaving nicely and we react in a positive way and praise them and are nice to them, that their behavior will, the nice behavior will decrease afterwards, and In the opposite way, if people are behaving badly and we criticize them and blame them, their behavior will actually get better. And of course, this is quite a problematic false conclusion. Now, you might have noticed already that we have a rather big problem here. As I said at the beginning, regression to the mean is about things, about situations that depend partially on predictable factors and partially on random ones. Kahneman made up a simple equation, which is success equals talent plus luck. Now the problem is, if success occurred in a specific case, how much talent is in it and how much luck? And we can tell this is the problem. Rolf Dobelli provides a couple of examples for the regression to the mean in his book, The Art of Thinking Clearly. Among those are the following three. Whenever my back pain is really severe, I visit a chiropractor and the next day it's usually better. Our last business year was quite bad, but we brought a consultant in and this year is much better again. My depression was quite bad, but after the therapy I feel much better. And you probably notice the problem. How much of this improvement is due to the actual intervention and how much is due to the regression to the mean? Now, I certainly wouldn't deny effectiveness to chiropractors and therapists, and maybe not even to all consultants. However, Dobelli clearly has a point here. In all those situations, there most likely would have been an improvement even if those affected would have done nothing. The back pain would probably have gotten better, so would have the depressions, and also the business numbers, the business results. So, did the interventions really have a significant additional effect? Was there an additional improvement? And we really can't tell, and this is important to note for our day-to-day lives. We can't really tell if our intervention was effective here, or if it is all just due to the regression to the mean. The only way to tell is if there is specific research available. And the best example for that are drug studies. Because if I am sick, especially if I have something like a common cold, then my condition will most likely improve even if I do nothing. And even if I take some homeopathic preparations or eat Tic Tacs, it will nonetheless get better. So in drug studies, there is always not just the test group where people get the actual drug, the actual medicine, but there is always also a control group who merely gets a placebo without knowing it. And then the scientists observe if those in the test group really improve significantly more than those in the control group. Because only if they improve considerably more, only then is the drug, the medicine, actually effective. Now, medicine probably isn't the best example for the regression to the mean, because our condition, there is a rather specific standard condition, and being sick is not so much a case of random fluctuation, but more of a specific problem, specific deviation from the normal condition. And of course, there are plenty of illnesses that will predictably get worse if left untreated. However, as I said, if I have a common cold, it is quite likely to improve on its own, and drug studies are a rare situation where we can, in an experiment, tell apart the regression to the mean and the actual effectiveness of the intervention. So I think it makes sense to mention that one here. On the bottom line, it is difficult to give a recommendation for action here, because I think it does make sense to intervene and to take action if things don't go the way you want, if you are unsuccessful, if your performance is really bad on some occasion. However, we should be cautious and not be too quick in declaring our intervention effective and successful, because the mere fact that there was an improvement is no proof of that. It could have just been the regression to the mean. Some of you might therefore wonder, isn't it better to just wait and see if things improve on their own? Well, this is difficult to say. I'd say it is certainly good not to panic if things go wrong, not to believe there is a big crisis if your performance is on one occasion worse than usual, but to keep in mind that there is such a thing as random fluctuation, and that due to the regression to the mean, things will most likely improve. What would clearly be wrong, however, is to expect them to certainly improve, because there is no guarantee for that. There is still a random factor there. And as I said before, partially predictable factors, partially random factors, and we can tell how much of each is involved. Maybe if we are unsuccessful, chance actually was on our side, but we really have no talent at all. And furthermore, we have to be cautious of the situation we are in. Maybe it is a situation where the regression to the mean does not apply, where everything depends entirely on random factors. In such a situation, we have to be careful not to fall victim to the gambler's fallacy that we discussed recently. To summarize it briefly, the gambler's fallacy occurs if I say, "Oh, I was unlucky so many times recently, I'm bound to have luck now. It is due, it is kind of guaranteed, because some kind of equilibrium needs to be restored." This is not the case. So be careful there. By the way, even though the regression to the mean is such a common and important and phenomenon that occurs in so many areas, it took scientists quite a while to actually discover it. It was only in the late 19th century when one Francis Galton, a cousin of Charles Darwin, discovered the regression to the mean for the first time. He made experiments with plants with some kind of peas, and he also observed the height in humans across generations. He noticed that exceptionally tall parents often don't have very tall children. Most of the time, the children of very tall parents are smaller than their parents. And the other way around, if the parents are exceptionally small, the children are usually bigger than the parents. So here also we have a situation where we usually approach the average, and this was one of the first examples of the regression to the mean that was discovered. How about you? Have you fallen victim to the regression to the mean and drawn false conclusions? Let me know in the comments. By the way, the last few videos didn't get that many likes and subscriptions. This is certainly bound to improve, isn't it? We will see each other again next week. For today, I'll take my leave. Have a nice day. See you next time.